Hello everyone, welcome to this video where we're going to be discussing how we can model curved Glulam members using STimber. Now in STimber, I have the interface open here, and you can see on the left-hand side we have different tools to define different types of members, 1D elements. So we have columns, we have beams, and then below that we have curved members. When I click on this left-click on this curved members option here, it allows me to specify the properties related to my curved member. So the type of element that it is, whether it's a beam, a column, a truss, basically the member type if you're familiar with S-frame, the material properties and section properties, the rotation of this member, and the orientation of that section relative to the member, and then we have the curve properties. So there's quite a bit of information to define our curve, and I wanted to go through some of that here. So let's just start by investigating some of these different parameters. You can see here that we have under the mode option, we have two options. We have centered or endpoints, and this is basically how we place our curved member into our model. Do we left click on the center point of that curve, or do we left click on the endpoints and draw the curved member around those endpoints? So I'm going to choose the center or the endpoints option here, and you can see here now on the preview of my model, it's showing me what this might look like. I've also got some subdivision properties which I'll define later on. I have this allow scale option which I'll also toggle later on. And in the angle, the sector angle of this particular curve, and the radius that this curve is going to take. And right below that we also have design parameters, which we're not going to dig into too much right now. But essentially when we draw this, I'm just going to left click. You'll notice here that it's going to place the first point of my curve, and now I'm basically pivoting around that point while STimber is waiting for me to place the second point. So I'm just going to left click the second point right here, and it's created a curve based off of those properties, the 30-degree sector angle and then the radius of 12 meters. And it's also created this curve ID, which I could then reference at any other time to apply to other members. If I wanted to create a new curve ID, after I've created this one, I click on this new option from the drop-down list. And it's going to give me the same set of parameters, but perhaps now I want to use the allow scale option. I'm going to use the allow scale option, which allows me to size my curve based off of the points that I click on. And you can see here we can even change things like our angle. I'm going to change this to 45-degree angle just to show you what that looks like. And I'm going to left click to start this. And as I move my mouse across the screen, it's going to resize this curve so the radius is changing as we go through this. I'm now going to left click and create that curve there, and you can see what it came up with as one example. And we're going to try adjusting some of the different parameters here. So let's just say now that we've gone through this example, we've created a new arc. So we can see that we've created a new arc with that 45-degree sector angle. I'm going to create new again. And this time I'm going to toggle off the allow scale option. And I'm going to adjust the radius. So I'm going to keep the same 45-degree angle, but I'm going to change the radius, and I'm going to change this to 8 meters. And naturally we'll see a different looking curve out of this as well. However, it is a little bit longer because I'm not allowing it to scale as I'm moving my mouse along. I'm using some predefined properties to specify this curve. Now we have some additional parameters, so going back to a new curve. And this time, what I'm going to do is I'm going to say, let's go to the centered option. And I'm going to keep everything else the same, but I'm going to use the centered option. And I'm just going to left click to place this. And you'll notice I only have one point to define this curve location now. And that will be the location that basically forms as our center point. And then the orientation is defined by the second point that I click on. And my curve beam will be drawn in those locations. And now let's continue with this type of member, and rather than using the default curve member property rotation of 90 degrees, I'm going to change this to a rotation of 0 degrees. And you can see right away the difference between this and the previous, which is right to this one here. Now the actual curve is in a different direction. It's curving basically about the local z-axis rather than the global z-axis rather than the global y-axis. Just the direction I happen to draw this in. And you can see that the plies of the Glulam are still in line with that curve. However, if I want to do the same thing, but this time, rather than having a negative 90-degree section rotation, I'm going to go with a 0-degree section rotation. I can go with perhaps a less conventional approach where I'm actually curving this in the weak axis. And you can see what we're left with now. Again, something that might be a little bit different than what you would normally design with. One last bit I want to mention here is if we go to this new arc and I create a new arc, and for the sake of this demonstration here, I'm going to say that we're going to use the endpoints option, and I'm going to allow it to scale, and I'm going to go back and change my rotation to 90 degrees, and my section rotation rather to negative 90 degrees. What I also want to adjust here is the subdivisions. So you can see here under the subdivisions option, we have this smooth subdivisions option, and we also have a discrete subdivision option. And we're going to do two of these side by side just to investigate. We'll try to make them the same size. You notice here I have the option here to specify basically the element size along the length of this curve member. So I'll go left click here and then left click here. And what I want to highlight is under the physical element view, you can see that it's actually creating these segments of analytical members that are 0.15 meters apart from one another. And that's what I can actually adjust. So if I go back to the object view here, and I go back to my curve member tool, I'm going to create a copy of this one once again. I'm going to change the subdivision option here to discrete. And you will notice that we can actually hover our mouse over this and see the difference between these two. So the smooth intersections are on the true curve, and the discrete intersections are basically more of a faceted curve, if that makes sense. Here we can define the number of divisions in our curve to be whatever we like it to be. I'll click on 12, and I'm going to draw this in once again, just like I had before. So, you know, from the naked eye, these two look very similar. But when I look at the finite element model, we can see that they are a little bit different. The differences are fairly subtle because we're just looking at a small segment and not a very tight radius. But we actually have different spacing. For example, I have a 12 segments along this particular member here that are along that faceted curve, whereas this one here has at every 0.15 meters of length, we're actually creating a new joint along that true curve surface or path. So just some differences in how we can represent these and how they can be used in our model. These can be obviously attached to other members, other elements. They can be applied, they can have loads applied to them, and obviously you can run and code check them as well. If you'd like more information about STIBR, feel free to check out our YouTube video, or also on the Altair 1 training platform, we have a dedicated training course on demand for that sort of thing.